All right, so let's look at this, guys. What we've been doing, we're still drawing shear force and bending moment diagrams, but one thing that's a little bit different that you might be staring at right now is that our frames are not nice and orthogonal. There's not a 90 degree here. It's some other angle. In fact, it's 45. Is this a valid structural frame? Yeah. You bet. We have to do a little planning when we move ahead. First of all, the shear force just below B will not translate directly into the shear force or the axial force to the right of B. So we'll have to kind of plan the way we want to do it. But at some point, we're going to have to get components of the shear and axial force on one side to relate it to the other side. Yeah, things that make you go, Now, let's see. Another thing to notice here is that this is a pin at A, and this is a pin at B, and this is a pin at C. So we can't draw a single free body diagram for the whole structure because we have two reactions here and two there, and we only have three equations. So it's probably going to be to our advantage to go ahead and take this thing apart and do the statics. So I think that's a good idea to do that. So I'm going to first let's see how I can work this in here. Just trying to plan my attack. I think I'll do this one here. So I'll draw AB here. Now, the reactions at the pin, I can draw in any direction I want as long as they're at right angles to each other. So why not assume that it looks like this and it looks like that? Can I do that? Yeah. Sure. And why did I do that? Because this one now directly is the shear for AB. Like that? I'm going to go up here at B and do exactly the same thing. So I'm going to assume that also. So let me kind of do this. I'm going to assume that I got a local x-axis. So I can now call this on this thing. I can call this AY and BY and AX and BX. You see that?
So we're just looking at member AB, right?
Just AB right now. Okay. And then I've got my load, which is applied directly to the side of the beam. And I can still turn that into a concentrated equivalent like we've done before. It's just the area of the curve. And what would that be? It's 6 meters times 3, so that's going to be 18. And it's going to occur right in the middle, so that will be 3 meters and 3 meters. It's almost like I took this one and just rotated it 45 degrees clockwise, or you can just turn your head 45 degrees counterclockwise, and you'll see that this doesn't look like a very complicated problem to solve. There is no moment at B because it's a pin. Now the thing we need to account for is when we transfer these loads over here. And I'll do that in just a second. Let's go ahead and solve for these guys first. So how do I do that?
You just look at it.
You just look at it.
AY and BY are both 9 kilonewtons.
How do you know that? Just by looking. Is that the best way to approach the problem? It's a good that you have that intuition, and you are correct. But I would encourage you to write the equations, just because sometimes things are not as they seem. So I will write the equations. So I'm going to sum moments at B for no particular reason. So about B, with right-hand rule, my 18 kilonewton force creates positive or negative moment. Positive. And it has a moment arm of 3. What else creates moment about B? Yeah, AX passes through B, so we're okay. And AX creates negative moment. AY creates negative moment at 6. And what do you know? What is the reaction at A? 9 kilonewtons. And a quick sum of the forces in the local Y direction, this kind of flipped over Y direction, says that I have AY acting up plus BY acting up, and then my concentrated equivalent is down. So BY is what? 9. Wow. Good job, Mr. Van Tilburg. Now what? Yeah, what does sum in X give you? Yeah, it gives you a relationship, right? Because we can't actually solve it. It just says that I have AX to the right plus BX to the right. All that says is that whatever way you want to do it, AX is equal to minus BX. So if I can ever find BX, then I got AX. So let's go look at the other section of the beam. All right. So I'll put this one up here. So what do we have? We have CY, and we have CX. What else do we have? 8 kilonewtons. 8 kilonewtons. And that's all 2 meters. Now, in this XY axis, I'll go ahead and emphasize that. There's the X. I can assume what I want here at B, but these things will eventually have to be put into the same system, right? So what you could do now is you could go ahead and take these components and break them down into their XY equivalents. Or you could probably solve for some stuff over here. Either way, it's going to be kind of tricky, right? So what do you want to do? Which one wants to be flipped? You want to take these and break them down into their components? See, I only have BY, so I'd have a partial piece, right? I don't know what BX is yet. This is actually pretty tricky, isn't it? Looks like a simultaneous equation is coming up here soon. Oh, great, thanks. So let me do this. Let's just put another force here, and I'll call it B prime Y and B prime X, just to distinguish them from these two. They are not the same. Now we know they're going to have to all go back together. But what can I get here?
You can find BY.
I can find BY and I can find CY, right? So let's do that. Let's get what we can. So I'm going to sum moments at C. And when I do that, both these 8 kilonewton forces are going to create what kind of moment about C? Positive. So there's my 8 kilonewton. The first one has a moment arm of 2. The second one has a moment arm of 4. And then I'll have BY, or B prime Y, which creates negative, and it has a moment arm of 6. So what is this BY prime? 8. That's it. I can sum forces in the Y direction and find CY. So I assume this B prime Y was up and CY was also up, and then I got 2 negative 8 kilonewton forces acting down. So Cy is also 8 kilonewtons. What can I do now?
So force X.
Yeah, so I've kind of got one component here and not the other. I've got one component here and not the other. That's going to be a mess to resolve all those into a common system. I'll probably end up with 2 equations and 2 unknowns. Wouldn't it be nice if I could get one of these X components somehow on its own?
That would be nice.
Yeah, could I do that somehow?
Can you break By and Bx?
What if I put the whole thing back together and did a free body of the whole structure? Can I do that now?
Yeah.
Because now if I sum moments at A, I don't have 2 unknowns at C. I only have 1. You want to do that?
Yeah.
I like that, don't you?
Yeah.
Because if I can find Cx, then I would have Bx prime, right? Then what could I do? Well, then I would have all of these, and it would be very easy then to resolve those into these components and add them all up and find what Bx was. Do you see that? I think that would avoid putting all this back together, which will, I think, result in a set of equations. So if I drew this here, now I already have Cy, right? Yeah. It's 8 kilonewtons. I don't have Cx. I also have this force, which is 18 kilonewtons. And, oh yeah, that was 3 meters and 3 meters. And then I had these forces here at A, but I don't really care about those because I'm going to sum moments about A. And when I do this, I'll know that this force times this moment arm and these 2 forces times their moment arms will be balanced by the Cx force. It'll be a long equation, but I think we can do it. So if we sum moments about A, let's see. So we're going to have about A, all these forces on the top will create negative moments. So the first one is 18 kilonewtons times 3 meters. The next one is 8 kilonewtons. Now what's that moment arm? Yeah, so I know the hypotenuse of this angle is 6, so what's going to be the horizontal distance? Yeah, we know the cosine of 45 is that side over 6, so
Plus this here.
so what is the side? 6 times,
Cosine 45.
yeah.
Plus 2.
That's, what is the cosine of 45? Oh, it's some 0.7. I'm just going to write it that way. So it's going to be 2 meters plus 6 times the cosine of 45. And then the next one is going to be minus 8 kilonewtons. It'll be the same 6 cosine of 45, but with 4. And then I got all the way over here. That creates positive moment. And that's going to be the same cosine of 45, but with 6. Wow, this is really tiny. And then CX. I ran out of room for CX. But it's going to create negative. Can I squeeze it in there? And it's going to be now this height, which is going to be 6 cosine 45. Or sine, doesn't really matter. We'll do sine, but it's the same, right, for 45. Wow. So I'll let you tell me what CX is.
You don't have it.
I can't do a Rain Man on this one. Only on Tuesday.
You got it. Use the best calculator in the world.
9. I have no idea.
How did you know? I don't think it's going to be that.
It's 9.
There's a lot of 9s on the paper. I just chose 9. This will test your computing skills.
42.
42.
No, it's like 42. Is that answer life? Right?
That's right.
Universe.
Yeah, that's what I got too. I'm not so sure about that. 20.7.
What'd you get?
Oh.
1,027? That's wrong.
No, I got like 20.7.
20.7. Anybody else get 20.7? Anybody trying?
I got 1335.
That's different than 20.7.
You know what? It is.
I think it's time to call Siri. Siri, what is the answer to this question? I don't know, but you need milk.
What?
You need it.
Oops.
Anybody got it?
We're getting it. 20.7.
Oh, there's two 20.7s.
I got 20.7 as well.
Oh, there's 3. Must be a... Did you get a negative, did you say?
Yeah, it's going to be negative.
Okay.
It's going to be negative. Good job.
So if CX is negative 20.7, that means that BY is 20.7. And if you know all that, then all you have to do is break these guys down into their components, and we can find the additional ones.
Do we need to find VX?
Sorry?
Like, do we need to find VX on the first one? It's not going to have any shear in that number.
Oh. You are correct. We don't have to find. I'm very good. We don't care about VX, do we?
No.
I forgot about that. We're not doing axial diagrams, are we?
No.
And we already got BY, so we're good to go there. But we did need... Oh, do we need VX here either, did we?
No.
We did it.
I'm a moron.
No.
Hey, no, we
I'm
did
an
it for
ignoramus.
we did it for the knowledge. Everything happens for a reason.
I'm a gullible. Why didn't you say this 10 minutes
Well,
ago?
I didn't think about it 10 minutes
Oh,
ago.
well, I'm glad you thought about it now.
He just wanted to solve the problem.
That's a very astute observation. We don't care about axial forces, do we? I guess in the complete sense of the problem we would.
You know what?
But to draw the shear force and bending moment diagram, don't need them. I knew there was a reason I put these on this angle. All right, so I assume by your general disruption that class is over. So what I'll do is I don't think these are very challenging shear force and bending moment diagrams, but I will draw them on this blank page and post them for you. So I'll see you Thursday. If you have any questions about the exam, just send me an email. I may not be around too much.